right, ladies and gentlemen, good evening and welcome to the Nelson Atkins Museum of Art. My name is Adam Johnson. I'm head of public programs here at the museum, and I'm very pleased to have you here tonight for the final event in our Behind the Scene series. Behind the Scene is a program that investigates some of the hidden investigations and conservation projects that are not always told. These are projects that really impact what you see, but you would otherwise not know the details about them. So far this season, we have hosted Scott Heffley, who is our senior paintings conservator, talking about the Caravaggio, talking about the Rembrandt. We've had Paul Benson give a talk. We've had Alicia Halligan, who is a fairly recent addition to our conservation team, talk about all of the preservation and cleaning that takes place in our Donald J. Hall Sculpture Park. Tonight, we have the benefit and the wonderful opportunity of hearing from the most recent addition to our conservation team, Saori Lewis, who is our photography conservator. Saori, I'm trying to think of what else I wanted to say. Oh, I know what I did want to say. This is actually Saori's public programs debut. But she is certainly an expert in her field, and I think she's going to be talking about a really wonderful topic tonight. Daguerreotypes, which in and of themselves are wonderful. Each one is unique, and I think she's going to share the story about conserving them, preserving them, and making them look really, really wonderful. Sarah, thank you.
Good evening, everyone. Thank you for coming. It really is beautiful evening. I bet it was difficult to come inside. Okay. Can you hear me okay? Okay. Here at the Nelson Atkins Museum of Art, we have very active and prominent photography collection. The rapid growth of the photography department started in 2005 when Hallmark card photography collection was gifted to this museum. Since then, the number of holding in the collection has almost doubled to over 10,000 pieces. So it is quite a collection, and along with the growth, I joined the museum a year and a half ago. That makes me the newest addition to the conservation. And it's actually, I'm the first photography conservator at this museum. And it's quite unusual to have dedicated photography conservation staff at museums. So we are really committed to this collection, and I am very privileged to be here. Okay.
Could you be a little louder?
A little louder? Okay, I'll try to hold my microphone, but okay. As a conservator, I have a lot of tasks, but I spend most of my day just looking at photographs. The 10,000 collection is quite a few, and I have so far looked at 3,000 of them, but I have a long way to go. So I do a lot of looking, examining condition at various occasions. I do research on conservation treatment, about art materials. I take light measurements of each photographs that are in the galleries to keep track of cumulative light exposure. But I'd have to say my favorite part is doing conservation treatment on photographs, and I especially enjoy working on the photographs that are going into exhibition and see the whole show come together. Right now we have Daguerreotype exhibition in the permanent photography gallery L10 in the block building, right over there and down the slope. It's called In the Looking Glass. There are 57 pieces on view, 53 daguerreotypes and 4 ambrotypes in the show, and 23 of the daguerreotypes received conservation treatment. Conservation work is said to be a three-legged chair. We need to have artistic sensibility, historic understanding of art pieces, and scientific understanding of materials. But when I'm faced with a photograph to examine or to treatment, what I want to know first and foremost is what it is, what it's made of, the material aspect. Okay, trying to get oriented here. Anyway, okay, so when you think of material that's associated with photographs, you think it's pretty simple. It's emulsion on paper or some kind of medium on paper. But when you start really looking into different components of photographs and the whole photographic processes from the history of photography, it's quite diverse. And daguerreotype is a great example. To work on a daguerreotype, I'd be working with 3 different kinds of metals, copper, silver, and brass. And there is glass, paper, wood, leather, pigment, natural resin. So it becomes quite a list. Aside the variety, diversity in the material that's used, there are many things that makes the daguerreotypes unique type of photographs. And but one of them, and the most intriguing part, is the way they look. They have this jewel-like quality to it. They have amazing tonal range, and they almost have 3-dimensional volume to those images. So I think I'd like to start with by describing what daguerreotypes are, what each part is made of, and through that I hope you have some good sense of why they look the way they do. Excuse me a second, I lost my cursor. Okay. Thank you. Okay, I brought some examples of daguerreotypes because, well, by the way, these are not museum collections, these actually belong to me, but I thought it's helpful to have some examples in hand because that's what these case daguerreotypes were made for originally. Okay. They're often housed in this case. There are several other ways of housing, but this is one of the most common and the one I'm going to talk about. Okay, so the case is made of wood and covered with leather that has decorative embossing, and they have these metal clasps to keep them closed. Inside, one side is an image, and the other side is often fabric lining with some kind of batting material, like a cushion, that's often silk or velvet material. Daguerreotype is the earliest form of photographic process that became commercially successful. It was first introduced to the public in 1839 in France. And when this new technology of photography became available, it was received, at least initially, as a way to record and share images rather than, say, work of art like paintings that are hung on the walls to be viewed. Instead, the daguerreotypes are portable. So when they have their loved ones' portraits taken, they would carry it with them and show it to their friends. They would look at it while they're holding it in their hands. So this system of presentation in a case worked as a convenient housing for portable aspect, but also it made the whole image a special object, as well as it gave protective enclosure. Okay. Inside this case, the image side actually comes out, and then it looks like this. It's called image package, and this style of housing embellishes the image beautifully, but it also works as protective, works to protect the very fragile surface of the daguerreotypes. Daguerreotypes have incredible, well-processed and well-stored daguerreotypes are chemically very stable, but they're really fragile, susceptible to physical force. And this is an unfortunate example. Even the slightest sweep with a really soft brush can leave these marks, like you can see in the close-up image. Once this damage happens, unfortunately, there's nothing I can do to remedy this condition. Also, dust particles that sits on the daguerreotypes are really damaging as well. So to protect the fragile surface from these factors, they are covered with a piece of glass called cover glass. But even the smooth surface of the glass cannot come in direct contact with the image surface. So there's a piece of window mat placed in between, and that's often usually made of brass or sometimes paper. And these three pieces are stacked together and taped together with paper seal. And to protect the paper seal, preserver that's also that's made of brass is put on top. And this is the structure of the image package composite. Now I'd like to focus on the structure of the daguerreotype image itself. Okay, so can I see a show of hands how many of you have held and looked at the daguerreotype in your hands? Okay, good. Maybe half of you. So some of you understand that it's kind of difficult to look at daguerreotype images. What often happens is that you look into it and you just see the reflection of yourself, and you kind of have to look for the image. It's kind of hazy. It's helpful to understand why it's so hard to see the image. It's helpful to understand why images, how the image is structured. So it's going to be a little technical, but please bear with me. Okay, this is a diagram of the daguerreotype plate as though it was cut in the middle, and we are looking at the thickness of it. Okay, the bottom is a copper plate, and on the image side is silver coating. It's pretty thin coating. The proportion of the diagram is a little off, but so silver coating that's polished by hand to mirror surface. On top of that are image particles. There are more image particles in the light area of the image and less in the dark area. This distribution of image particles gets determined based on gradation of light to dark when the plate is exposed in the camera. And that this gradation makes up an image. Are so good? Okay. So it seems simple, but the tricky part is that the image particles are made of mostly silver, and they're just sitting on silver surface. They're same material, same color. So how does that make up an image? There are two things at play here, and these are what makes daguerreotype so unique among all other types of photographs. One of the key factors is alteration in topography of the image surface. I like to use the analogy of fog on mirror to explain this. Imagine a mirror that's super clean, smooth, and when you breathe on it, the spot you breathed on gets all these little water droplets, and the area looks white. And water droplets, the water does not have any color, but you can still see it white. What's happening is that in the flat area, on the left of this diagram, light comes in and it gets bounced back at the same angle it comes in. Whereas in the area of droplets, when light is dealing with curved surface, the light gets scattered. And scattered light looks white, and it makes things look hazy. So So this is something somewhat similar to what's happening on the daguerreotype surface. These image particles are not embedded in the silver coating, but they're sitting on top. And they're creating topography like water droplets on glass. So the area of image particles appear whitish because of the scattering light. But to make this white areas to pop as highlights, you need the rest of the area to be black. This brings us to the second key point, the fact that what's behind these image particles is a mirror surface. It's like a mirror. So if you can reflect something black, you can gain the contrast you need to complete this gradation. Okay, I know it's a little confusing, so I made a little video to try and illustrate this mirror idea a little better. If I can find my cursor. Okay. So you're able to see, you're first looking at the reflection of the little shamrock sticker. Then only when the black card was inserted, you saw the image of the Indian chief with some clarity. Again, the daguerreotype plate is really a mirror with some really fine texture. So it's only when you reflect something black that you see the image gradation complete and see the image as they were photographed. And in the next part, I'm going to insert white card instead of black. What do you think? Right, see? Okay, so it looks kind of like a negative. This is because the white hazy highlights are not quite as white as the white card that was inserted. So what's supposed to be highlights are then kind of functioning like a shadows and reverses the image. It's kind of tricky thing to get the head around, but wrapped around. But this I call this the negative mode of viewing, and it's helpful to record certain damages on the daguerreotype plates, and you'll see some examples in a little bit. So to summarize this daguerreotype optics, if you will, it is not the particles with grays or colors to make an image like all other types of photographs. Instead, it's strictly the topography on the plate surface and its interaction with light, right? And its relationship with the dark reflection on the mirror surface that makes up the daguerreotype image. I'll be talking about these mysterious image particles, and so let me show you what they actually look like. To be able to see these image particles, we're gonna have to get really, really close to the plate because they're super tiny. This plate is about 4.5 inch tall by 5.5 inch wide, and we are gonna zoom right into the area of red box. Can't see it yet. Can't see it yet. And in fact, they're so small that we need a microscope. This is an image through an optical microscope. At this magnification, you can kind of see kind of granular nature of the surface. To the right is a higher area where there are small image particles snuggled up to one another and scattering light and the white. And on the left, there are much less image particles. You still see the white dots, but it's reflecting the black lens of the microscope I took this image through. But to really be able to distinguish individual image particle, we need a much powerful microscope. And these are images from electron microscope. The scale bar at the top right corner of each image, the little sticks, are equal to 10 micron in length. And these are images of a daguerreotype grayscale from, that were made specifically for studying the daguerreotype optics by Susan Berger. And they are arranged from left to right, from highlight to shadow. The images on the top are the same area as the bottom, but at higher magnification. The high magnification images help you see the shapes of the image particle, whereas the low magnification images help you see the distribution of the particles. In the highlight, the image particles are very small and regularly sized, and they're nice round shaped. It's a little hard to see, but they're really consistent. And they're close to one another and evenly distributed. Whereas when you step down to or up to shadows, the image particles get bigger and bigger and kind of odd shaped. And by the time you get to shadow, they're kind of rocky shapes, and distribution is kind of irregular. They're clumps, and then they're a big area of nothing. This morphology of the image particle, morphology and distribution of these superfine image particles interact with light in a very specific way that creates unique light reflectance, and that makes daguerreotype images. These image particles are 0.1 to 1 micron in diameter. To give you a point of reference, human hair is about 40 to 120 micron in thickness. So they're about 100 times smaller than the thickness of our hair. Very tiny. And that is precisely why daguerreotype images can be so sharp. I brought up this image because this is one of the pieces that's in the exhibit in L10. Every time I see this image, the lace work looks so fine, and especially the lace work over her arms. It almost looks like it's draped over her arms and have such a sense of volume. And in my opinion, daguerreotype is the only flat two-dimensional, semi-two-dimensional medium that's capable of this much of conveying this much of sense of volume. This virtual depth and infinitely high resolution makes daguerreotype images so special. Now that you understand the image structure, I have some tips for viewing them. The best way to look at daguerreotype is to be wearing something black. If you have some lighter color clothing on, you can have a piece of black board or something black at your chest. Hold the daguerreotype right in front of you and look for the reflection of the dark clothing in the plate. That way you get the complete tonal gradation. Another point is to let the light fall onto the plate from the side. When they prepared the daguerreotype plate, they always, the polishing of the plate was a big part to create mirror surface, and it was done by hand in this linear back and forth movement. And they always finished the polishing by going horizontal direction. If the image is vertical and portrait, the polish line is going this way, and if the orientation is landscape orientation is going the long ways. There's a reason for this. When light comes in and it hits the plate and hits the polish line perpendicular, if the light is perpendicular to the line of polish line, it catches light and it scatters light. And you know what happens when light scatters? It looks hazy. But that doesn't happen when the light direction is parallel to the polish line direction. And in the 19th century, the light source was often coming from the side, either from the window or candles. They didn't have overhead lights like we do now. So practitioners then worked with their environment and always finished the polishing on the horizontal direction. So remember to let the light in from the side. The last point is to dim the light, the room light and the ambient light. It doesn't need to be pitch black or anything like that, but when you have a lot of light falling on the plate but dark in the surrounding area, you get a lot of contrast, and the contrast will help you see the image clearly. And I recently discovered this. table at my house, and there's a window right next to it, and I had the daguerreotype on my dining table, and it was in the morning, and I just looked at it, and the image looked really nice. It turns out that the window, light was coming from the window, and it was about 8 o'clock, and we didn't have the room light on. So a lot of light was falling onto the plate, but the ceiling was in the shadow, so it was reflecting the dark ceiling, and great, so try. Okay. So the viewing of the daguerreotype requires a lot of control of light, and that is why it's so tricky to display the daguerreotypes in the gallery space. It would be fun if I can just have the daguerreotypes out on the table and let everyone come in and take it to the window side, but unfortunately that's not realistic. So to make it work, our lighting engineer designed special casework for the daguerreotypes and ambrotypes, and our gallery light is dimmed really low. What's so great about these cases is that the light sources are mounted inside the case, so nothing can get in between the light path between the light source and the plate, so nothing can cast shadow on it. And the room is dimmed and the walls are painted dark, so you don't get any reflection in the daguerreotypes. Also, a lot of light is falling on the plate, and the dark surrounding give you a lot of contrast. And it's actually almost impossible to find that viewing angle in our galleries. Our gallery lighting is really unique display. That I think we only have this casework done, and so I hope you will have the chance to go see the exhibition and enjoy the full potential of the daguerreotype images if you have not already. When an exhibition is scheduled and all items that goes into the show is selected, the first thing I do is to look at the condition of every object to assess the condition, conservation need or mounting, housing need, etc. Almost all the plays, I think, that went into this exhibition are being displayed for the first time in this museum, which means many of them needed some help. Earlier, we went over different components that make up the daguerreotype, which means each of these components can develop its own problem and obscure the image. For instance, broken case hinge is a very common problem. Broken hinges make it difficult to handle, and the object cannot be secured to the display mount safely. Luckily, this part is repairable. What you often see done is just to put black fabric tape on the exterior side of the case hinge, but that hinders the original leather material in the case. Also, the adhesive on those tapes are not necessarily good quality. In conservation field, we only use material that has good aging property and that things that are tested to be safe for use around the material we are working with. So what I did for this piece was to first lift the leather along the spine on the exterior and interior side. Then I prepare a Japanese paper strip and tone it to match the color of the original leather and insert it between the wooden frame and the leather and set it down with adhesive. Japanese paper is very thin, so it doesn't add the bulk, but it's really strong and it stays flexible for a long time. So it's a really ideal material for repair of the hinge. So I do work on the inside first and then do the exterior. This is after treatment. Another frequent problem is related to the cover glass. This plate, as you notice right away, is all these white spots scattered over the image. This is accumulated dust and glass corrosion material. And since the daguerreotype is a mirror, you're seeing a reflection of all these spots. So this is doubly spotty looking. And at this point, this three-dimensional illusion of the daguerreotype is hindered, and it's really obscuring the image. This plate, the plates are supposed to be sealed in image package to keep clean, so you might be wondering how it can get so dusty. But the paper is trying to hang on to the glass and the metal, and paper is not as strong as those materials, so it breaks. And to seal to attach the paper tape to the plate and the mat, to put into the plate and the glass, they used flour paste, and that can seeps into the paper and makes the paper brittle. So it didn't always stick to the material really well. So it's not unusual to see even the bugs and insect casing and things like that inside the case. To improve this condition, in this case, I simply took the image package apart and replaced it with new cover glass. It is a straightforward treatment, but the improvement is quite remarkable. Now, there are two different schools of thought about deteriorated cover glass. On one side, the cover glass is original material, and the original gold glass should always be kept with the plate despite its condition. The other argument, which is the one I subscribe to, is that the object's primary value is the image on the plate as it was realized by the artist. So the glass should be replaced with a new material if it's necessary to protect the image from being damaged. So when I observe glass corrosion, I change the cover glass and keep the original glass in our archive file. And another approach I will use is if the corrosion is at a really early stage, I will take it apart, wash it and dry it thoroughly, and put it back together, but reverse the orientation so the chipped side is facing out. This is another common issue related to cover glass. We call this weeping glass or glass weeping, and you're actually seeing liquid condensation on the inside of the glass. This is caused by still and humid air that's trapped in the package that starts to interact with sodium in the soda lime glass. And over time, sodium melts into liquid and seeps out to the surface. Once glass is at this stage of weeping, glass is pitted as it has lost the solid mass into the liquid. And once this advances, small glass debris forms and it can fall onto the daguerreotype plate. And this is what happens to the plate when glass corrosion debris stays in contact with the surface. These are images of the surface of the daguerreotype at magnification. In the top image, you see dendritic corrosion material that was induced by glass debris. And when this condition advances even more, it looks like this. And this material formed really close to the plate, and it's really difficult to remove once it gets to this point. Glass corrosion only goes in one direction. Once it starts, it's going to continue to corrode, and there's nothing I can do to reverse this deterioration process. And what you see in the bottom is the corrosion of the daguerreotype triggered by brass mat. Since brass mat is in direct contact with the plate, it inherently interacts with silver surface. Also, it corrodes, so you would think brass does not corrode, but given the right or wrong condition, it can corrode and it can drop the corrosion material on the plate, and that starts to interact with the silver surface in its own way. So our best approach is to keep these conditions from happening by means of providing a good storage environment and good housekeeping. But once the corrosion is at this stage, intervention becomes necessary to keep this condition from advancing. Some of the pieces in the exhibition had already reached to the point where corrosion corrosion is so prominent that it is distracting to the viewing of the image. This plate had corrosion spots scattered all over the top half of the image. And when corrosion is this advanced, liquid immersion treatment becomes necessary, since the surface is too fragile to take any kind of mechanical manipulation. And this is after bathing in high alkaline water. You can see before and after overall. Other than corrosion caused by glass debris and poor environment, inappropriate treatment can cause tarnish on plate. This plate had been cleaned using chemical called thiourea in the mid-1990s by the owner at the time. And this chemical was commonly used to remove tarnish of daguerreotypes in the late 1950s. It was really popular because it was really easy to administer, and the result was really instant. But over time, photography conservators started noticing these yellow spots formation on the plates that were treated that way. And once this problem was understood, diarrhea treatment became obsolete among photography conservators, and it has not been used since 1979. What happens with thiourea is that the chemical interaction that makes the tarnish go away actually forms a compound that sticks really close to the daguerreotype, and it cannot be washed away really easily. And the material is invisible at the time, but it continues to interact with the silver over time and eventually develops into these yellow spots. This plate had a record that it was cleaned with thiourea in 1996. 17 years later, it developed these brown spots. These spots are also called Daguerrean measles because that's what they kind of look like. And it's kind of seen in the overall of the normal light image, but this is when the negative viewing mode is helpful to see those tarnish. This is before and after treatment. And a close-up. So these damages are quite common with daguerreotypes. This is partially and maybe simply because they're old, but also because many plates have been kept in private homes. They're passed down among the family, or they're with the collectors. And normal residential environment happens to be not optimum for preservation of daguerreotypes. Daguerreotypes of excellent content and quality are really hard to come by, and they're really expensive. But you can still find them at antique stores and maybe estate sales, certainly on eBay. And the medium of photography, I think, lends itself to the enjoyment of collecting. So I think it might be helpful to talk a little bit about identification and care of daguerreotype in case you have some daguerreotypes or are interested in acquiring them. I have images of 3 plates here. One is a daguerreotype, one is a tintype, and one is an ambrotype. These are 3 most common types of non-paper photographs. And we also call this category cased photographs because they are often cased. And because of this non-paper and cased aspect, they often get confused. But it's not, once you know what they are, it's not too difficult to identify. Certainly you know how to identify daguerreotypes by now. But I made a flowchart for identification of daguerreotype, identification of cased photographs. Does it work like a mirror is where I start. You know that daguerreotypes are essentially mirrors, so you can, if you can look into it and see reflection of yourself clearly, that would be a daguerreotype. If that is hard to tell, try reflecting something white and see if you can view it in the negative mode. Only daguerreotypes does that. And I recently discovered if you have a smartphone or iPad or something, bring up some kind of white blank screen and shine that on the daguerreotype. That really helps you see picture of object and can't really play with the light, try looking at the highlights. Highlights in daguerreotype are pretty bright and white, or at least have some luminescent quality to it because it's light being scattered. Whereas ambrotypes and tintypes have opaque, sort of grayish, creamy highlights. So that was a daguerreotype. Ambrotype and tintype are essentially the same photographic process, but on different bases. So if the image is on glass, that would be ambrotype. If it's on metal, that's tintype. If the object, the image is housed and you cannot tell what the base is, try looking at the area of the highlight, the brightest highlight and darkest shadow right next to one another. And you might need a little magnifying glass, but try looking at it from different angles. And if you can see white and then a little bit of space and black underneath, that would be ambrotype. That is because ambrotypes bear only highlights on the glass, like the image on the top. They're the same plate. The right is the ambrotype without a black background. Unless the ambrotype is made on colored glass, the rest is clear. And the black is provided by a black piece of black paper or fabric behind the glass on the opposite side of the white image material. So that's why there would be a little gap. Or sometimes the back side of the glass is painted black. In that case, you often see little cracks in the paint, and you can see the crack formation under the image. I have some tintypes here too, so you can experiment with that. Okay, so the dimension behind highlight, that was the ambrotype, and that's the tintype. To keep daguerreotypes in good condition, storing and handling them properly is very important, and I also recommend condition monitoring. For storage, I recommend you keeping them in dry and cool environment where there's as little fluctuation as possible. So avoid storing or displaying them near the heat vent or the areas that gets direct sunlight. Bathroom will be terrible. It has huge fluctuation in humidity and temperature. Recommended relative humidity of cased photographs, daguerreotypes are 40 to 50%, but seasonal changes are inevitable. So try to focus on minimizing the daily fluctuation as small as possible. It is difficult to keep the whole house environment stable, so I recommend that you keep them in a box or some kind of enclosure that will work as a buffer for the temperature and humidity shift, as well as it will keep the object clean. I have some do's and don'ts for handling. First, handle them with clean hands. Simple but very important. Do not touch, but even with clean hands, do not touch the metal parts with bare hands because oil in your hand can start corrosion of the metal. Second, keep the image package sealed. Image package is the composite of the plate, mat, and the glass. I cannot emphasize enough how fragile daguerreotype surfaces are, so keep it closed to avoid any accident. And you might be able to go ahead and open it, but to seal it back up, you need the specific material and specific environment, and it's quite tricky to do. And if you leave it unsealed, the dust is going to get right in there and start corrosion. Also, the humidity and temperature shift can be more drastic. Third, when you look at daguerreotypes in case, don't open the cover all the way. But opening the case all the way really stresses the hinge, and that's how it gets broken. So hold it, support it with your hand or a book or rolled up towel or something to limit the opening angle. The fourth point is do not close the clasps unless it closes naturally. Clasp is another part that I see broken really often. And if the object doesn't want to do something naturally, forcing it is probably going to break it. So avoid forcing clasp. Oops. Okay. Using the cursor again. Okay, the monitoring is the last point I have. And monitoring condition really help you catch things early when something goes wrong. So try, look at your daguerreotypes, which you should do anyway, once in a while, and look at it with good lighting condition, and try looking at it with different lighting condition, the normal light, negative light, and also raking light help you see glass corrosion happening. And make note of anything that you didn't see before, or if you suspect if tarnish is advancing or glass is starting to do something funny, make notes. And also, you can seek for qualified conservator through this website of American Institute for Conservation. And they can care for daguerreotypes. So I hope the tips were helpful, and with your new understanding of how the image works, I hope you will enjoy those beautiful photographs even more. Thank you very much. Any questions? And so how, what?
I just think I've seen some of them hand-tinted.
Sure.
How
Yes.
do they do that without damaging?
Well, very delicately. There are different methods, but they can really carefully apply some kind of resin to work on adhesive and kind of dust the pigment over, or by brush, really lightly apply. They probably don't do this, linear motion. They probably just dot the pigment on, and sometimes they set it with just the moisture from the breath. It's really gentle process. Question? That's a good question. I would love to see it, but the image from the electron microscope is actually excerpt from a book. We don't have an electron microscope. I would love to see it, but I do sometimes see corrosion starting around near the hand coloring. So I'm sure it's pretty fascinating to see it. Yes.
Some of these images are 160, 170 years old. Do you know that they look like they originally did when they were made? Or it seems to be a pretty stable surface if it's kept clean.
I think well-kept pieces, I bet they look really similar to when it was made. But another thing we know about daguerreotypes is that the image particle, the development of plates is done with mercury vapor, and that stays with image particles initially, but over time it evaporates. So I've read, I haven't witnessed it firsthand, but I read that over time, as mercury component evaporates, the image becomes stronger because the wavelength that the daguerreotype reflects shifts a little bit because of the loss of material, and that happens to fall right on the area we see best. So it's quite fascinating. Yes?
Were there clear demarcations of dates between when people generally did daguerreotypes and when they became classical symbiotes?
We don't, they're not really clear, I suppose. The daguerreotypes became really popular right after it was released, and especially in the US. So the release year of 1839 through the 50s, maybe mid-60s. But by then the collodion process, which is tintypes and ambrotypes, became widely available, and they were much less expensive. So at that point, probably the balance shifted. I cannot, from my memory, tell you when that shift happened. Yes?
One of the
He was trying to remove dust. Yes, it's actually, that piece is not our museum collection, but it's a study research resource. And one of my friends actually brought it for me to use as study resource because he was trying to clean it and damaged the plate. And I was like, I had no idea they were that fragile. Yes. Yes.
So when you showed the particles, the deposited particles, do the deposited particles make the surface reflect darker or lighter?
It's supposed to make it look lighter because it's scattering light. And given that the surrounding area is darker, then it's scattered light, whitish haze. So it's all proportional. And by the way, I forgot to mention, I brought out these samples for you. If any of you are interested in handling daguerreotypes, I welcome you to come up and try looking at it in the gallery light.
Saori, thank you. Would you like the light fully on? Would that be better for viewing?
Sure, yes. Oh, and I should probably mention now that since we don't have a sink here to wash your hands, I brought gloves if you wanted to handle daguerreotypes. Okay.
Saori, big round of applause for Saori.